This is a narrated version of the presentation that I gave at the ICA Commission on Generalization and Multiple Representation. It was a workshop held in Vienna on the 26th of September. This paper is jointly authored with Nick Gould and was inspired by some of the collaborative work that he and I have been doing together. And the key message that I want to convey in this short presentation is an argument that we need to explore ideas of automated map generalization that go beyond the topographic. And I think we need to think differently about the whole process of map generalization and not to see it as so much a cartographic process, but to see it as something in which we are making sense of things by looking at things at different scales. And throughout this presentation, I want to stress an argument that has been made by others, in fact, stemming right the way back to some of the earliest work in 1991. I want to stress the idea that the geographic is incredibly important to the design task, and that therefore we need to fundamentally underpin map generalization by modeling the geographic. So what we have then right now is what I would call a topographic legacy. That is to say that most of our research has focused on the topographic. We've looked at frameworks in which we have existing data that are typically supported and maintained by National Mapping Agency, and what we seek to do is to reduce that data content as we move to smaller scales. The customer is quite general in their requirements, and the questions that people ask are fairly open-ended, or rather quite general in their nature. So we're working from an existing data set, and as we move to smaller scales, so we see that there are constraints that are imposed upon us which force us to undertake certain changes to the map content, and so the process of generalization is driven by this constraint-based approach. What I want to do is just explore the context of map generalization where we might start from a blank canvas and have a much stronger thematic focus. So let's think of a particular question and look at some of the issues in the context of geographic modeling. So imagine that the question posed by the user is this one. I'd like to have a map, please, that shows the name and the location of the 10 longest rivers in the world. So that then is the thematic task. And, as if by magic, here's one I prepared earlier, or rather, here's one that I took from the web. And what we can see in this map is a range of information, some of it very salient, some of it very poignant, strong emphasis. We can immediately see where those 10 longest rivers are, and we can see a range of other information, some of it textual in the bottom right hand corner. We can see marginalia, we can see the marking and the locations of the oceans of the world and the continents. It's probably a Mercator projection. And there's a range of information that helps to provide a critical context to this key question, where are the 10 longest rivers in the world? Okay, let's look at that in a little bit more detail. Well, first of all, we've had to think about what the overall image is going to look like. Do we think we could get 10 rivers on a piece of A4 paper or an A5 piece of paper? All right, yes, I think that seems fairly achievable. So from a thumbnail sketch, our understanding of the rivers of the world, that would require us to map it at about a scale of about 1 to 150 million. So what we observe first of all is that we need ways in which we can link the query to the selection of scale. And I think there's a great opportunity amongst the map generalization research groups to look at ways in which we can derive some notion of scale from the form of that query. And I don't think we really have those kinds of tools in our toolkit at the moment. All right, the second point I want to say is that we also need to be able to understand the relationship between the salient and the contextualizing information. So here the salient, the key information, are rivers. We need their length and their name, and we need to be able to sort through the rivers for the whole world in order to derive that information. We might want to include information about lake systems, because often major lakes are associated with major rivers. Additionally, we need contextualizing information. So in this case, it might be the outline of the continents and their name. We might also include a relief map of the world, because relief is a key driver or governor of the pathways of rivers. And we also might need a data set of the sea regions. So we can separate between the salient, and the salient then governs the contextualizing. And again, I would argue that we need to do more research in this field. I don't think we quite have those models that enable us to say, okay, given a particular salient information, what is the contextualizing information that needs to go with it? How have we decided, and on what basis have we decided, that we need other information such as the continents and the rivers and the seas in order to provide a context to that information? How do we do that? That's clearly geographical information. So we need geographic reasoning to help us select the contextual based on the salient. Let's imagine we change the task slightly. Let's imagine that instead of 10, you said to me, okay, I'd like a map, please, that shows the 30 longest rivers. Well, now our map starts to get a bit busy. Even just showing 30 instead of 10, we know, we can anticipate that that map is going to become a bit more busy. Can we still do it on a piece of A5 paper? Is 1 to 150 million still appropriate as a scale for showing this type of information? So we need to think then in this context, we need to think about how these content models are linked to generalization methods. So here what I'm arguing is that moving from 10 to 30 fundamentally changes how we go about approaching the map generalization task. And I would argue that this is an important area of research that at the moment, again, we don't really have the toolkits for this. I thought about this question and I attempted to come up with an answer. Here it is. Perhaps we could color code the continents according to the longest rivers. So we could maybe group rivers according to each continent, and then we could color code the continent. I don't think it's a very imaginative solution, but it does illustrate how perhaps a small change in the nature of the query can lead to a fundamentally different solution. Is this solution adequate? Is it better or worse than the previous solution? Is it good enough for what it is that I'm trying to do? These are very difficult evaluative questions. I don't think we have the toolkit that enables us to answer this type of question, but clearly it's a geographic one. We know that 30 rivers are busier and are going to make it more difficult in terms of a cartographic design solution than if I'd asked for 10. The other thing that is very apparent to those working in the field of map generalization is that there's a real difference in terms of how we treat the salient information, very different from how we treat the contextualizing information. Definitely there's been some research done in this field, but this again is another area ripe for further development. How do we change and alter the degree of map generalization according to whether the object is critical, salient, and needs distinct clarity versus the background information that perhaps is less critical, is open to greater flexibility in how it's mapped, but provides a critically important context. So how do we treat these different salient and contextualizing layers of information? And I think again we need to think carefully about how we can develop ideas around these sorts of geographic notions. I think the difference between salient and contextual is not a simple binary. So here in this example we can see on the left important information relating to the delta. And we can imagine that a delta, typically associated with some of the really major rivers of the world, could be considered to be an important piece of information. In the first example, in the first solution I showed you, deltas weren't marked. But at this finer scale, we can imagine that we might include this information, and they've been summarized as a dot feature in the map on the right. So what I'm arguing here is that as we change scale, the notion of what is salient and what is contextual changes. Again, I don't think we've really developed our ideas in terms of what these relationships are, how they're modelled, and how we give emphasis to the changing relationship between what is deemed to be salient and what is deemed to be contextual. In this example here, I would argue, it seems to be in some way scale dependent. Our decision to include the delta is only undertaken because we can show it at this fine level of detail on the left. Another area which is well understood by those people working in the field of map generalization relates to the connection between different types of geographic entities. So, for example, we know that the rivers connect to the sea, and this is a relationship that is critically retained despite different types of generalization. So this is a generalization of a river network in New Zealand, slightly tongue-in-cheek. We can see that no matter what generalization is undertaken, we can clearly see that it remains connected to the sea. So how do we model these explicit and important relationships between, in this case, the river and the sea, such that the relationship is maintained throughout the generalization and abstraction process? It's another area where the geography is governing or constraining the nature of the cartographic generalization. The next observation that we make is that different types of geographic entities exhibit different types of behaviours, and those behaviours need to be treated in different ways. So we might have a river network, we might have a road network, as we do here in these two simple examples on the right-hand side. They are both networks, but they have fundamentally different behaviours. We can immediately identify them as being quite distinct. We don't have road networks that look like river networks and vice versa. So my seventh observation or requirement would be that we need to try and do more in the way that we develop our models such that they are sensitive to the geographic nature of this phenomenon. That the river network, for example, is acyclic, or that the river flows, whereas a road network in the lower example has flows in both directions, and we can fundamentally edit it in different ways. So we need to try and build this into our modelling. They have different behaviours, and we need to reflect that in the way that we apply different generalization algorithms. When we look back through the literature, these observations that I'm making here today are no different to those that were made quite a number of years ago. In fact, I was reading back through the article on map generalization authored by Babs Buttonfield and Bob McMaster, and I picked out these three quotes. The first is from Mark Armstrong. He wrote, "Cartographic generalization will not reduce to a solution that is in lockstep with a set of deterministic rules." David Mark made the observation that in order to generalize real-world objects, we need to consider the geography of those spaces. And finally, Tim Niergis was commenting on the idea that when we come to generalize objects, we need to consider not just their internal properties, those things that are specific to the entity, but also we need to take into account the external meaning. In other words, what is the relationship among other phenomena? So the example I just gave is the external meaning would be, what is the link between a river and the seas and the oceans? That needs to be modelled, not just the properties of the network itself. One of the things that I've been recently inspired by is this idea of making explicit these relationships as a way of trying to incorporate and then use them to control the generalization process. So here, for example, was my poor attempt at a model that tried to explain the relationship between rivers, how they're connected to other natural features, how their shape are governed by the morphology of the landscape, how they interact with anthropogenic features, the way in which, for example, bridges and roads are built across river networks, they themselves, of course, being networks as well, the relationship between mountain chains and the landscape, how rivers form part of a network, and so on and so on. So here what I've tried to do is to try and explore some of these relationships. My argument is that if we had some sort of an ontology, then we might be able to identify those key pieces of information relating to at least the contextual information. So in this case, that rivers form networks, that they are attached to lakes and deltas, which are themselves connected to coastal systems which connect into the sea, and that those river networks on the left-hand side run across continents, their shape governed by the mountain chains and plateaus of the world. So here I am trying to look at what the connections and relationships that exist between these different entities, and that this might provide a basis by which we can then govern we might be able to incorporate some of these geographic models within the map generalization process. This final slide is from a storybook of Pooh Bear and Twiglet, who go in search of the heffalump. And they go around in circles and they end up following their own tracks. And they are convinced that they must be getting closer to the heffalump because there seem to be yet even more tracks as they go round and round in circles. My feeling was that when I read those the chapters in the book from 1991, I sort of felt that we had failed to really take on board some of those signposts that had been given to us by the likes of Tim and Mark and David. And it's imperative, I feel, that we take a stronger inclusion or make more of an effort to include the geographic in the way that we model the cartographic. So I conclude with these points, that in order to be able to reason about the design process, we need to incorporate geographical knowledge. And I would argue that that geographical modelling needs to centrally underpin the map generalization process. More broadly, from an epistemological perspective, we should perhaps be seeing map generalization as a process in which we seek to reveal different patterns and relationships among geographic phenomena. In that sense, I would argue that map generalization forms an integral part of the exploratory process. In that sense, it's a part of exploratory data analysis, and that we're using map generalization as a way of trying to examine and unearth patterns inherent in the data. It's an abstraction process, and that we need to think more about that geographic dimension when it comes to modelling that process.